this is me doing a voiceover right now because I very stupidly did not have the OBS, the desktop audio for OBS turned on right away. So here's the setup. I came into this Discord channel for Flat Earthers and asked, why does the sun set? And they kept talking about this tabletop demonstration as if that proves anything. So they kept showing that you can make a sunset happen with a sun that's, above the ground or whatever. And it's a neat little demonstration of what they need, but there's so many problems that I kept bringing up. For one, uh literally nothing else behaves this way, because if the sun and moon are getting away from us, they need to shrink in size, and they don't. uh Literally everything else does. I'm not sure if that part of the conversation gets recorded or not, but they did show a source where you can see the sun changes by like less than 1% in diameter, which if the earth is flat, it needs to it needs to shrink by far more than that. So it's kind of a non-starter. And they claimed that, oh, the person, they went over the footage. No, the video is highly edited, so the video is very suspect. Anyways, the audio comes on here in just a second, so enjoy.
That's great. So when I go swimming at night and I'm right in front of the light, so it's like inches from my face, it looks kind of small. But if I swim away from it, the light's going to appear to get bigger and bigger and bigger, right? Because there's light attenuation. But if I were to drain that pool and change the bulb, you would see that the filament is actually quite small. So I would disagree with you in saying that nothing in reality does this. When you're looking at light through
Oh my
very
goodness.
dense water, it's very analogous to looking through, tens of miles through atmosphere, right? It's the same thing is happening. So I think that things do this if you're talking about a really bright light source.
Uh okay, so if I watch a car, a boat, an airplane, literally anything move away from me, it gets smaller. The sun does not do this. That's a problem. The
Yeah,
thing
it
about
does.
water, we're not talking about looking at things in a pool in a backyard. We're talking about in the atmosphere. Now you say bright points of light do this. I would agree that bright points of light very far away, like on a cell phone tower or something like that, the glare they produce looks bigger than the actual light source. However, uh, uh, you can do this with what are they called? Wind towers, because they tend to. Oop, hold on.
Oh,
Look at
just
the
so you know,
text. Look
Alpha,
at the
I'm
text
pretty
channel.
sure we talked to him before in the other Discord. I'm
Yeah,
pretty sure.
there's a snippet of him putting something up there on his
However,
screen,
I
so you can see.
think he made a false equivalency there. The sun is not like an airplane or a boat or a car. The sun is very different in the amount of light that it puts out. So I would say that this is
Yeah.
not equivalent whatsoever. But if somebody else wants to take over,
Well,
Yeah,
I
I just
I just like the sun doesn't change in angular sizing. That's just patently false. It does. With the solar filter, without a solar filter, it's the same.
Planet Peterson. Are you streamed, by the way? Just
But they
wondering.
try to
That
do,
way.
they try to say it doesn't change in
What's up?
angular size because they're just looking at it, right? Looks the same to me, that type deal. But if you actually like take any of these videos with a solar filter and actually measure the diameter by counting the pixels, it always gets smaller every single time.
So, anyways, I'll
Yeah.
just say one thing, and then I'll have to dip. Sorry for that, but if I were to look at a series of like wind turbines, they have those bright lights on top of them. They get, although they produce a glare, they still get, they look bigger the closer they are and smaller the farther away they are. So this, we don't have something that works here.
Yeah, we
Yeah.
do.
So here's something you're not considering. Have you ever seen like a red hot torch? It's like the heated end of like a piece of metal.
Yeah,
They heat it up to red hot.
yeah.
Why does it look bigger than it actually is?
A glowing piece of metal.
Yeah. So if you heat up the end of a torch to the end of like a piece of iron till it's red hot,
Yeah.
if you heat it up till it's glowing hot, why does it look bigger than it actually is?
They don't look bigger to me. I mean, I can
No,
imagine that it does
they do.
because
They
there's.
do. It's well known that they do.
Okay, well, I've
because
done it
it's so
before,
hot.
and to me, they don't. But I suppose the light that it's producing, if it's producing an intense enough light, it might make the edges begin to, or the edges might be like a little fuzzy or whatever because of that intense glow.
No, what happens is the temperature difference causes refraction, right? Because you have a
Oh,
temperature gradient.
okay.
So this is well known that if you heat something up till it's red hot or glowing hot, that it'll appear bigger than it actually is.
Okay.
So the sun is pretty hot, right?
I thought the sun didn't get smaller the farther away it got because of a lensing effect in the atmosphere. So you disagree,
Yeah.
or is it more than one
What
thing?
is refraction?
The bending
Is
of
that
light as
lensing?
it goes through a medium and
Yeah, so
changes
that's
speed.
lensing, right? We make lenses based upon refraction. And when you have a torch, like I just said, that causes refraction, which is effectively a lens to light, and it blows up to the size it appears to be, because it's like a lens.
Okay, well, that GIF that was, it's actually pronounced GIF, but that's a different argument. That GIF that was being shared, the heat produced by the candle is not what is making it appear the same size as it travels away. It's the construction of the lens.
Yeah, it's a reverse Fresnel lens as far as I know, that particular one.
Okay, so that.
So they're looking at through the Fresnel lens, not the typical way. They're looking at it coming from the other direction. Now, there's also a video on Action Labs. Are you aware of that YouTube channel?
I know about it, yeah.
So he actually he takes a fish tank with sugar water, and he puts like I think it's like a little sun in it, and like you can see just from moving it, right? The object changes size, but the gap between it and the edge of the tank actually shrinks, appears to shrink, right? So the gap gets smaller, right?
Yeah,
And
but
that's all they
nothing
do.
else does this except apparently the sun and moon. That's a
No,
huge problem.
no, it's not a problem.
Nothing stays the same size the farther away
Only
it
a
gets
problem.
from you.
It's only a problem if you presuppose that everything in the sky should behave the same way that everything should behave terrestrially. And before the globe model, nobody thought that that was the case.
Okay, so the explanation for why the sun stays the same apparent what do you call it? Radial fuck, what do
Or
you call
angular
it? The
diameter. Well,
angular
technically, it would be
resolution.
the visual angle, or
Yeah,
the
the
angular
angular
diameter.
resolution of the sun never and the moon never
Angular
changes.
diameter.
So why
Angular
does
diameter of the sun and moon do change. I don't know why you keep saying they don't change.
they well, because they do. The moon
No, they
does.
do.
The
It's
moon
been
does a
measured.
little bit because the moon gets closer and the moon's a lot closer to us, and so if it gets a few tens of thousands of miles
Okay.
further away,
I have a video on my YouTube channel. It was taken by astronomers at the Chilean observatory in the desert. Now they use a solar filter. They film the sun. It's time lapse. Now you can take that video and you can take a screenshot and you can compare the sun when it's high versus when it's near the horizon, and you can count the number of pixels, and it's 13% smaller at the horizon.
oh, I doubt it, but you got a link
Well, you
for
can
it.
doubt all you want. Nuh-uh is not actually a reputation.
Yeah, I know. That's why I asked if you have a link for it.
Yeah, I can post a link in the chat. But I challenge you to do this. All the videos, they can't be like, the sun is only like 2 solar diameters above the horizon. You can't really measure it that way. It has to be a time lapse where the sun is like at least like 5 degrees above the horizon. Measure it when it's at its highest point by just like there's a bunch of software you can measure freaking the amount of pixels something is, and then measure it at its lowest point, and it'll have changed size. Have Globers go, here, look, the sun doesn't change size, and go into it, it does every single time.
Cool. Yeah, send me the link.
Yeah. I might actually have screenshots hanging around somewhere.
Hey,
too, so you don't have to
Well, I'm not going to take screenshots.
do you
I need to
often
look at
planet-
it on my own.
planet-
yeah, no, I'm gonna post
Pla-
a video. I was gonna give you both,
Yeah,
so you don't
let
have
me
to
ask-
do it.
Well,
Let me
no, I'm
ask
still
you
going to do
something,
it
Adil.
on my own.
Planet Peterson,
Yeah.
do you often come in here into this channel? And if you do,
Literally
could you
never
stream
been
some of
here
your stuff
before.
in here? And well, I'm asking, is there any way possible that you could stream in your channel? Because some of the guys you face on TikTok are just They're just basic bottom shelf, flat earthers. You need to come in here for top shelf arguments. If you're gonna do it right. Don't be arguing those guys over there because they don't know anything. You got to come in here for quality arguments. Now, if you're gonna do that, make sure you step foot in here when you see some of the people from the 24/7 team on here, and then go ahead and start your stream and see how it goes. Because I doubt that you're gonna have the same type of reaction that you do with those TikTok lobers or flat earthers, sorry, or the YouTube flat earthers. Not the same quality as you do when you come in here. So I'm just saying, if you're gonna do it, come in here and do it. We're always up and we're always having people in here. So just saying, if you're gonna do it, you might get a lot of content out of it too. So
Yeah, if you're gonna do it right. I hear what you're saying.
I'd say.
I
Because
wanna.
TikTok
sorry.
usually cancels and sorry, I was just gonna say TikTok usually does a lot of canceling on this type of arguing. So I don't know how that fared with you, but from our side, when we do stuff, they canceled some of the channels that we.
I've never had a live stream get shut down when talking about the shape of the Earth, but a lot of flat earthers, they will spout some anti-Semitic or anti-vaccination stuff, and then that does get you in trouble.
Yeah. Well, I'm just saying for future reference, and then you could just plug the channel because we'd like to get 24/7 kind of a little bit more acclimated with everybody else that's out there. So, and you can come in here and stream and just say, hey, look, I'm going to debate these flurfs or whatever, and let's see, you know what I'm saying? The people that react to it. Anyways,
the TikTok
just
flurf community is
and those were
also
probably
full of
globe Earth believers, by the way, Peter. Those were probably globe Earth believers. We just were talking about that earlier, actually. That's something that afflicts globe believers.
Yeah, but I mean, just saying, if he's going to do it, then do it right. Do it with at least the ability to have people to articulate their points versus these guys that you probably talk to.
For sure.
They just probably think that the Earth is flat. They don't know it. So
sure,
it's different.
I can't stick around for too much longer, but I would like to hear your guys' response to this because I've talked about it before, but I just made a video about it that no flat earther.
Just for the record, I posted those videos, 2 videos in the chat. Both of them use solar filters. One was actually used a theodolite, I think. So yeah, they're both in the chat.
I got the first one where it's dark with a red circle. So you're talking about
yeah, that's a solar filter, whatever. Yeah.
Okay, I'll open up.
And the other
I'll take a look.
Shocking solar diameter change while equinox.
Sure, I'll take a look at them later. I think there's another really huge problem with I think there are a lot of problems with the flat Earth model, but one that I think is kind of inescapable. I don't know if you guys have ever heard it before. I'm interested to see what you have to say about it. If you have 2 people in the southern hemisphere and they both travel south, they get closer together. And that makes no sense on a flat Earth.
Are you sure about that?
Yes.
What flat Earth model have you given us?
Well, it doesn't matter because south is all directions south are radial directions away from a central geographic north. And you can't get closer together if you travel due south on a flat Earth. It cannot happen.
South of the equator than north of the equator. How does that make sense on your globe?
The whole first half of what you said was completely garbled, so I didn't hear any of it.
Yeah,
time zone.
You're working on. Yeah,
No,
hold on,
we're not talking about
you're
time
working
zones.
off planet. You're working off of an assumption that you have this type of model that you're looking at flat Earth. Like when people say flat Earth, how would you describe it? Just based on what you've heard about it.
That the Earth is flat.
Yeah, I understand, but what comes to mind what image do you think about?
That it's flat. It doesn't really matter. I know people quarrel and bicker over, well, is there anything beyond the ice wall? We don't know. And so on. That actually is completely irrelevant. Any flat Earth would have a geographic North Pole. There wouldn't be a South Pole. That just obviously can't happen. And if you travel directly away from that geographic North Pole, going true south, then you would always be traveling. The distance between any 2 people doing that would always grow. And that happens until you get to the equator, but then you get closer together, which is exactly what you would expect if the geometry of the Earth is a sphere.
Do you have
can we
evidence for
ask
this?
for your evidence for that, though? We want
Yeah.
your actual evidence. We don't want your claim. We know what the claim is.
So you're
Because effectively,
We want
what
the
you're
evidence
asking
for the
just-
is,
claim, right? So you're just saying
so
they
you're
get
just saying
further
it's
apart.
false.
Okay, do you have any evidence? Well,
Sure.
I don't have to
Just
say
Yeah,
makes
anything.
you
I
can
need
measure
evidence.
you can measure the distances between
No,
city.
you think it's already happened, so I want the evidence that it already happened.
Yeah, you can measure the distance between.
No, don't tell me what I can do. I want to know what was done already.
So you can measure the distance between.
Why are you just repeating yourself?
Why
I
are you
don't want to know
interrupting?
what
Cow
I
says.
can't. Oh, because see, you're
Interrupting
giving
Cow
me a
says.
hypothetical, and you're supporting
not
your
a hypoth-
hypothetical
it's
with
not a
another
hypothetical.
hypothetical. Yeah, it is a hypothetical. It is a hypothetical. Until you provide evidence, it's a hypothetical.
Yeah, well, I'm just describing to you the matter of fact geographical situation we are in, which is that
would be the event of someone actually doing it. That would be the fact.
everybody in here has been extremely polite except for this guy. So are you guys going to
I
do
don't give a
anything
fuck
about it, or
politeness.
do I
Home
have to just
policing
suffer
isn't
through
going to help
this?
you. Home policing isn't going to help you. It really isn't. I'm
Okay.
asking you. I think you're being dishonest. That's why I'm acting like this.
No, I'm not being
asking you
dishonest.
specifically, what's the evidence?
The evidence is that cities that are on the same meridian in the southern hemisphere, if you take 4 of them, the 2 in the north are farther apart than the 2 in the south.
Okay. How do you know that?
On the same meridian?
Because it's been met. Yeah, meridians are lines of longitude.
It's been measured.
I know what they are,
What
but you just
instrument?
said they're on the same. So you're saying that the ones that are north of the equator at 0 degrees latitude are closer together. The ones south of the equator at 0 degrees latitude, they're closer together. Are they on the same meridian line?
Yes.
Okay.
I didn't
Meridian
100% follow
lines
what you
say
said
this.
there, but you go to the southern hemisphere, you take 2 cities that are on the same meridian, and then you take 2 other cities that are either east or west of them that are on a different meridian, but the same one in relation to each other. The 2 cities north are farther apart than the 2 cities south.
That makes more sense now you said it that way.
Yeah.
Now I understand what you're saying.
And it's kind of hard to explain without like a picture or something, but
What actually is a meridian? Do you know how we define what a meridian is?
a meridian is
what the longitude lines are. What are they? What do they represent?
What do they represent? Well, in my view, they represent a straight line from the geographic north to geographic south pole.
They actually represent the position of the sun.
No. I mean, you can describe them. You can describe them that way.
Because the longitude, there was a whole contest about longitude, and it was about making an accurate clock.
Yeah.
Okay, that's based upon the sun, right? Our time system is based upon the sun.
The sun finds its way through every
This
single
is why I
meridian
give you
in
attitude,
a day,
bro, because
but that's
you're
not
fucking
what
dishonest.
meridians are.
They are.
Lines of longitude are determined by the sun. This is not debatable.
It's just 100% false.
GMT, zero line of meridian.
The sun,
that runs
it's
straight
dark
through
where I
London.
am, so am I on a meridian?
Yes.
Okay, then it has fuck all to do with the
Does it
sun.
go away when you...
Dude,
Wow.
we're talking
What
about
the
the
opposite
sun
of
being
time.
at 90 degrees at the zenith, solar noon,
That
and how that's
changes all the
divided
time throughout the year.
and how
you
that's
look at
divided
those figure 8
Why are you
pictures.
talking?
Because what you
That's why
said is
it's
incorrect.
divided. That's why, my friend, now you try my patience now. That's why it's
I'm
divided
not scared of
incrementally into 24 portions. It's to do with the sun's meridian angle, 90 degrees at the solar noon.
Yeah, except
Greenwich Mean Time,
except
0.
that literally changes every single day.
Oh my god, it's not getting this.
Oh my god.
Okay,
It
so check
it
this
does.
out.
I know you
If
guys
it's
have
an
seen
hour,
the figure 8 photos
We're
of
going to
the
try
sun.
and find my location.
What?
I live +1 GMT. Where am I in longitude?
Off the top of my head, I don't know. +1 GMT? Is that General
that's
Mountain
1
Time
hour
or
past
Greenwich Mean Time?
And Greenwich Mean Time is 0, so I'm now on +1.
Does that mean you're to the east then?
Yes.
Yep.
So you would be in Germany or, I mean, anywhere south of that.
No, what's my longitude? You can literally find your longitude by knowing the hour.
Yeah, you can do that.
That's because that's how it was designed. That is what longitude is.
It's my word.
So minus 15 or 15 west or 15 east is what they would call it, right?
Yeah, sure.
Because 1 degree per hour or 15 degrees per hour. So if it's 1 hour difference, then it's 15 degrees.
Sure. What does 15 degrees in relation to what?
360 degrees.
Greenwich Mean Time in this case.
So not the sun. So it's 15 degrees of,
it is the sun.
It's a 15-degree angle that's been swept out from a position on the Earth. So it's mapped directly onto the Earth. It's not the sun. So thank you for trying.
No, it's mapped with the sun, right? So we look at the sky. The entire coordinate system is based.
This is just
no,
so
you don't.
stupid.
You don't. You could say it's stupid. That's not an actual argument. The entire
I explained why
coordinate
it's wrong.
system. Well, I'm gonna explain why it's wrong, dude.
Okay? You don't measure longitude in terms of what time it is. You measure it in degrees, and the degrees are in relation to tracing degrees like a circle around the Earth. It's mapped to the physical Earth.
Yeah. Let me prove my point. Okay, this is super simple. We black out the sky. You can't see the sun, stars, or anything. How do I find my latitude and longitude?
It's dark outside. You can't see.
Yeah, you can't see anything. There's no stars. There's no sun. There's no moon. There's no planets. It's completely fucking black. How do you find your latitude and longitude?
Oh, I would use GPS.
Jesus Christ, these fucking people
are. What would you do? So you're telling me that GPS can't tell you where you are?
Oh, dude, this is so low tier. GPS uses something called Earth-centered Earth fixed, okay?
It uses global positioning satellites,
no,
but
it
whatever.
converts it into latitude and longitude. It's converted to that. But it uses Earth-centered Earth fixed. It's technically a tangent plane. So, but the point is that you can't find your latitude and longitude because that entire coordinate system is built upon the sky. It's not built upon the Earth. We map the sky to the Earth, ex post facto.
Sure. So we use the sky to determine like the shape of the Earth. Like, for example, you can't see the North Star from the southern hemisphere. Flat Earth debunked. But we use that to create a model of a globe Earth. And what we did was we mapped as we designed that map or globe or whatever of the Earth, we put lines on it, and these longitude lines are measured in degrees. And that is, when we're talking about degrees, we're talking about circles going around what? The sun? No. So it has nothing to do with the sun. You can derive it that way, but that's not what it is.
And how did you find your longitude in the first place on the Earth without the sun?
How did I find, or how, like...
Anybody. The longitude's been around since Ptolemy. How did they find longitude before GPS?
So if they're traveling, they would use the sun to figure out where they are in relation to other people on the planet. But again, just because you can, what did I say earlier? No, I forgot. You can determine what your longitude is based on the sun, but that's not what longitude is.
Yes, it is.
The lines of longitude are drawn on the Earth.
Yeah, cool, but that doesn't mean they're not based on the sun as the spatial reference from which they're quote unquote drawn on the Earth.
Yep,
there's also lines drawn on the Gleason's map.
Cool. So again, 15 degrees in relation to what?
The sun's movement over 24 hours, completing 360 degrees, 15 degrees per hour, which is your meridian line.
So you're telling me 15 degrees means that the sun has moved 15 degrees?
What would you think it fucking means?
It means 15 degrees. So you take the Earth. It doesn't matter if the Earth is flat or a globe, but a circle has 360 degrees. That's why we have 180 degrees to the east, 180 degrees to the west. The degrees are measured either, you could take it from the North Pole for a flat Earth map from that, or for a globe Earth, it'd be kind of weird because you'd be drawing that from like the very center of the Earth. But in either case, it's in reference to or with respect to the geometry of the Earth itself.
Why can they do it from the center of the Earth?
Sorry?
Why can they do it from the center of the Earth?
Why can they? Because Earth is spherical?
Yeah, but if you've deleted the Earth, right?
Deleted the Earth.
You just delete the Earth. The Earth's not there. You're in the center of the Earth where the Earth was, and you deleted the Earth. Would the entire coordinate system still work? Now you have no Earth.
You could spin.
Yeah, the entire coordinate system still works because it's in the fucking sky, dude.
Get the sand out of your vagina, dude. Holy shit.
Dude, it's
you
in
could
the sky.
You could spin in a circle if there was no Earth. Yes, congratulations.
That's right.
Profound
they assume
question.
the Earth is a point. Listen, they assume the Earth is a point at the origin of fucking coordinates. Yes, they do. You don't know anything that you're talking about. You really don't. I don't know how you got this many subscribers on TikTok.
Hold on.
Because I'm not like you.
Planet.
Yeah, that's a great argument. You haven't refuted a thing I said. You just been in denial.
Yes, I have.
Hold on, Planet.
Chat GPT this shit, dude.
Yeah, it's called the celestial sphere, Planet Peterson. I thought you might have known about this already since you've been in the argument.
The celestial sphere is a point?
Yeah, it's called celestial sphere. So it could be thought of as concentric to the Earth or the observer. When you type in celestial sphere and you look up the Wikipedia, it's going to tell you that. That's the answer. Concentric to the Earth or the observer. So just as India was saying, it's concentric to you. So essentially, you're like the center of the universe. So radial spokes coming out from your vision, seeing the world around you. You can see at an angle of view to things that are in the sky. So that's exactly how you see things, the world around you. So you could view the Earth everything's concentric to you. That's just true.
What does that have to do
I don't
with
know why you don't know
latitude
this.
or longitude?
Because that's how you're making latitude and longitude observations from celestial bodies like Polaris. Yes?
No.
What do you mean no?
You could use Polaris to find your latitude, not your longitude.
All right, so then that's the point that I'm making. So if you're able to do this, then you can see Polaris at an angle of degree in the sky, depending on your geographic location.
Yeah, it always matches your latitude.
Okay, but all of this has to do with what you can see in the sky. This has nothing to do with the terrestrial sphere that you think you live on, or anything to do with it. So it has everything to do with how you... Yes?
So I agree that you can map your location using those things, but the lines of longitude and latitude are literally, I mean, we made them up, but they are positioned on the Earth because, again, we went over this so many times. What 15 degrees in relation to what? Not the sun.
Okay. No, it's relation to the observer. That's what it's. Whoever the observer is, that's in relation to.
False.
But you can't.
It's in relation to a location.
All you want. It literally is a model for predicting where the sun is, when sun rises and sunset times. They're all observer dependent. All of them.
That's
called the equation of time. It's
15 degrees in relation to what?
The observer.
No, false.
Yes, that's true.
No. It's like the only thing you can say. You sure you got something else?
You gotta look this up, man.
So let's
say one more point, bro.
Let's say I'm in the.
You can say no. Hold on 1 second, because you said something that I want to address. You said that latitude and longitude on the Earth. You cannot create latitude and longitude independent of the celestial sphere. They cannot be created independent of that. If you do not see the sun, stars, moon, all that shit, you cannot create a system of latitude and longitude. It just cannot be done.
You really have to look this up, Planet Peterson. You're just wrong if you're going to persist. You are, bro. You really have to look it up.
That's great. So let's say we're both on the equator, but in different places.
Why do you persevere, bro? I don't get it. Are you still trying to barrel through this? You're not gonna win, dude. You're just wrong.
With stubborn-headed people like you and
you're stubborn,
Mr.
bro,
Miyagi
you
here, probably not.
Sir, have you looked into this information?
I've looked into every more things than you could look into in 10 lifetimes.
Let's then talk about the celestial sphere. Talk about the celestial sphere and make it make sense to how we can see everything in the night sky, according to how we're trying to use either right ascension or declination. I need you to make that make sense to us, because it sounds like you don't know what you're talking about.
Yeah,
be honest, bro.
I don't take orders from you. So let's say we're both on the equator.
It's not that you don't take orders. If we're in a good faith discussion, sir, you're going to be able to articulate your point. What do you mean take orders? Are you able to do it or not, Planet Peterson?
So let's say we're both on the equator.
You're not answering my question, and that
and I'm not going to. So I don't know
because you're obfuscating. Because you're obfuscating.
There.
No, you're not going to, because you're obfuscating, and everybody who's listening to your 300,000 subscribers should know that you're an obfuscation artist. You just like to run away from the question. Answer it.
Yeah, I'm
Do you know
literally
about
not
the
going to
celestial
do that.
sphere or not? Or
I don't know
not,
what
sir?
you're talking about when you say that. I may be able to understand it, but I'm going to ask my 15-degree or my question about the equator.
Why? If you're running away
Because
from
I'm
this one, that
proving-
means you don't understand the
You guys
premise.
are the ones running
that-
because I've been talking about the
No, I
same
don't
thing
think
this
so.
whole time.
You don't know how the right ascension or declination is garnered, or longitude and latitude, if you say that it's not from the celestial sphere, because astronomy and celestial navigation are both based upon this. So you are right now
That's not what I said
incorrect.
no to earlier. I said no to it's based on an observer, which is obviously false.
It is based
And I
on
can
an observer, and it's not false, because if you go look at the information tells you, planet. Why do you deny that? You go look it up right now.
That it's
it will
false
say
right
that.
now.
How?
Great. So
Go
let's
ahead,
say
tell
we have
us how.
Yeah, let's say we have two people. We're both on the equator. Okay, one of us is in on Lake Victoria. I know that's on the equator, and the other person is they're hundreds of miles either east or west. We determine that we are 5 degrees in longitude apart from each other. 5 degrees in relation to what?
Based on the observer?
No.
You got him right there.
From the geographic North Pole in your model.
That's exactly what he was saying.
That there's no observer at the geographic North Pole. So it's not in relation to an observer.
But your example was based on 2 observers.
Oh
What
my
the very
god.
fuck do you
They
think?
are not 5
No,
degrees apart from
Hey.
each other.
Hey.
We're not making a 5-degree rotation from one person's position to the other person's rotation. In your view, it's from the geographic North Pole. Even in your guys' worldview, that's not how it works. Now, maybe you meant something different by it's based on an observer, but that is not how it works, even given your view.
I wonder what the Greenwich Observatory would have to say about what it measures with regards to meridian lines, the sun, and how we divide time across the Earth. The observatory that looks at the sun.
5 degrees in relation to what?
5 degrees? What are you talking about now?
The exact same thing that I brought up less than 2 minutes ago. We determined our longitude is 5 degrees apart in relation to what?
If you're making the observation and you measure 5 degrees, that's in relation to your measurement of the sun. 5 degrees, it has moved across the sky. If it moves 15 degrees, an hour has passed. It now has another ground position an hour away in an eastward direction.
So me standing on the... Okay, so great. So this is what would have to be the case in order for your claim to be true. You and I are both on the equator, just like I described earlier. We're both looking at the sun, and if we're 5 degrees apart in longitude on the Earth, that means my angle, that means our measured angles of the sun in the sky will be exactly 5 degrees different.
If you're measuring angles, yeah.
Okay, maybe that's the case. Maybe it is not. Let's find out.
Okay, it's quite simple. This is how we derive meridian lines. 15 degrees an hour because of the sun. That's what the thing that's travelling in the degrees that we're measuring. It's the sun.
Do you guys just like literally not agree that if we are, this is assuming the Earth is flat, if our longitude is measured 5 degrees different, that means that the angle from both of our locations to the North Pole is 5 degrees? There's no way you disagree with that.
Are you measuring an angle?
Yeah, 2 points, 2 points the same radius away from the center. Yeah, that's the situation we're in right now.
Cool. As long as we're measuring angles.
Do you agree?
With longitude? You're saying longitude is 5 degrees from the North Pole?
Yeah, if we
What are you saying?
Yes, if we are both on the equator and we determine that our longitude
You mean longitude or latitude?
I mean longitude. Those are the lines that go north-south.
The long lines. That would be the sun. No. I don't. Explain yourself.
I feel like I need a picture or something. If we are both on the equator, 5 degrees in longitude apart, what that means is the angle that our positions make, if we connect our positions with lines that go straight north to the North Pole, is a 5-degree angle. I'm not trying to debate this. This is what would be
with longitude.
Yes, exactly.
I think you're confusing longitude and latitude.
I am not. I haven't talked about latitude at all tonight.
All right. So when you say they're on the same line of, when they're on the equator on the same line of longitude, 5 degrees apart, these degrees, are they in longitude or latitude?
That's not what I said. I said we're both on the equator, 5 degrees in longitude apart from each other.
Okay, so not on the equator then.
Yes, we are both on the equator. Holy fuck, you guys.
I got you.
Yeah. So what is created is between our positions. If you take our positions and draw straight lines to the geographic North Pole, you have a 5-degree angle.
Okay.
Yeah, that's what it means to be 5 degrees in longitude apart from each other.
Yeah.
Now, what you guys are also claiming is if we didn't do that, if we didn't look to the North Pole, if instead we each looked to the sun, we're going to be able to create a 5-degree angle. Now, I'm trying to, it's kind of hard to like find a website to find what the positions of the sun are at 2 different spots and talk to you guys at the same time, but that is doable. Sorry, I didn't hear you.
Timeanddate.com and suncalc.com. Yeah. U.S. Naval Observatory.
Oh, yeah, I'm on time and date right now. Yep. But I don't know how to get 2 spots that are... I don't know how to plug in latitude and longitude onto... Oh, you can do location. Okay.
Yeah, so here's the funny thing. That model for predicting where the sun is, it's not a globe. There's no globe in the mathematics. Called the equation of time. And it's observer dependent. Okay, I know you believe something else. I don't know if anyone ever told you it. I doubt it. Didn't correct you either.
About some random website. I don't need some random website.
The equation of time? It's not a random website.
You said the website uses the equation of time, or did I misunderstand?
Okay. Time and Date and SunCalc use the U.S. Naval Observatory's model of the sun, which uses the equation of time.
Okay. Does the equation of time assume the Earth is flat or something? Like, what's the point?
Well, no, because it's based upon the sky. It's not based upon the Earth.
Okay.
Your coordinates, like if you look at the sky, you have that so-called celestial equator. And where you are in relation to that and where the sun is in relation to that. And if you know the time of year, your date, you can predict when the sun will rise, where it'll be at any particular point in time from your location. Because your location is based upon looking at the sky. Where am I relative to the celestial equator? You don't need to know anything about the Earth at all. You can be a point, you can be whatever.
Okay.
Celestial sphere, which Alpha was trying to tell you about.
Yep.
The entire coordinate system is based upon this.
Okay.
Astronomy and celestial navigation. Yep.
Yeah, though they use a different convention. Right? They use like right ascension and azimuth or something as opposed to. There are celestial latitude and longitude. I mean, if you get stellarium, do you know what that is? You could actually turn on the grid and it'll show you the latitude and longitude lines in the sky.
Yeah. It's got a function for that.
Cool. So
that's because how measured from. They're measured from the sky. Right? Latitude are circles of equal altitude around the ground position of Polaris, measured in angles. 45 degrees, you measure on your sextant. 45 degrees line of latitude. Angle measurements. Every single longitude and latitude is an angle measurement to something or other in the sky.
Cool.
Observers.
I'm gonna have
observers.
to. Yeah, I'm gonna have to. Well, without getting back into that, I'm gonna have to go here in a little bit. But so, are you guys just saying that? Let's say we're in Australia. If we have 2 cities, or 4 cities actually, 2 that are on the exact same line of longitude, and then 2 others that are to the east or to the west that are on the exact same line of longitude, you guys are just saying the ones to the north are not actually farther apart than the ones to the south?
Oh, first of all, you're basing what you're saying right on the Gleason's map, right? Now the Gleason's map, you think that like if I draw like 2 points in the south, I can use that as like a way to measure distance. That's not how distances are actually measured on the Gleason's map. All the distances are measured from the center. So you would measure from the center to a point, you'd measure to the center to the second point, and then you would do a formula to figure out the distance between those 2 points. You wouldn't draw a straight line between them because the Gleason's map isn't made for navigation. It's made to calculate the sun and longitude.
So
It says it right on it. It says sun, time, and longitude calculator.
that's fine. So was that a yes or a no?
What do you mean? Yes or no to what?
Well, I asked a yes or no question. So are you saying that
Restate your question then, because maybe I didn't understand it.
you have 2 cities, 4 cities actually, and we have 2 pairs of cities, okay? 2 of them are on the exact same line of longitude. The other 2 are on a different line of longitude, but the same line of longitude with respect to each other. Are you with me so far?
Yeah.
Okay, cool. 2 cities directly north-south of each other, 2 other cities directly north-south of each other. In the southern hemisphere, the 2 northern cities are going to be farther apart than the 2 cities to the south.
No, is this on the globe or the Gleason's map?
Well, on a flat Earth, the ones in the south would have to be farther apart because that's just how south works on a flat Earth. But on a globe, they would get...
Nah, I just explained it to you. You're doing distances wrong.
Okay, then you don't... This is just basic geometry. Straight lines going away from the North Pole radially in all directions. They're going to get farther apart from each other.
Those radial lines
get
in all
farther apart
directions.
from each other. They never get closer together.
Yeah, they're farther apart on the map, but in reality, if you take that map and do the formulas that are printed on the map, you get the distances, they're not farther apart in actual physical distance.
And why is that? So, in other words, the
I don't
map
know.
is inaccurate.
He's the one who made it. Pardon me? It's not accurate, then the globe's not accurate.
Yes, it is, because on the globe, it would tell us that the cities to the south are closer together, and that is the case.
Yeah, and if you take the Gleason's map and do what I just told you.
Yeah, but you don't have to do that with the globe model.
No, how would you do it
you
with
have
the globe
to you
model?
have to make your map fit reality, whereas the globe fits reality.
What makes you say that?
Because you just conceded.
What are you talking about?
You just said if you take the Gleason map and then you do some number magic and then whatever, then it does match reality. But on the globe model, you don't have to do that. It already matches reality.
You do.
No,
you do.
No, you don't.
You have to do the Haberstein formula. What the fuck are you talking about? If you want to find the distance between 2 points on a fucking globe, you have to do a Haberstein formula. Yeah, dude.
You have to do it. What?
There's something called the Haberstein formula. So if you want the distance between 2 points, the great circle distance, right? So here's your 4 cities, right? And you want to know how far apart they are? How are you going to figure that out?
You could do that. You could literally just use Google Earth or Google Maps as well.
What do you think Google Earth uses and Google Maps uses in software? How do you think it calculates it?
Zeros and ones, probably. So the thing is, when you do this on a globe map, you don't have to. It gives you the accurate numbers. I don't have to say.
No, you mean like a physical globe?
Well, you admitted that with your flat Earth projection, the lines are getting farther apart, but in reality they don't. Whereas on the globe model, they do get closer together, and that is the reality of 2 cities that in the southern hemisphere are south of 2 other cities on the same line of latitude. No, longitude. Sorry.
You're confusing something, and I think
I'm not.
this is the
I'm
problem.
not confusing anything. You actually
Yeah.
conceded the point.
No,
You're holding
I
up a
said
false
all I said was the distances is identical
You said your
because it
map is
uses
wrong.
the same. Dude,
It's a false
listen,
dichotomy.
stop talking.
No.
Because we're using the same coordinate system, right? So we have a coordinate system that's based upon shit in the sky. And when you use that coordinate system and use it to figure distances, you're going to get the same result. And you apply one formula, the Habersign formula, and the Gleason's map applies a different formula, and they get the same result because they're using the same coordinates. These are geometric transformations. That's all it is.
Do you want to know why as well? Because this map that you keep giving us, this flat Earth map with the ice wall of Antarctica around the outside, is a global projection onto a AE azimuthal map. It's your map. You just squished it out. You're giving it to us like it's ours. It's yours. You just flattened it out.
And give you anything. I just told you the reality that you
You
agree
did.
with.
You did. You
that
said your
south
model.
That
you said your
lines
model.
of
Yes,
longitude
in this
are
mod,
radial
my friend,
lines south
friend,
going away from the geographic
Planet,
North
can you
Pole.
let him finish? Planet. I know you're eager, man. Let him finish, please. Just let him
This
finish.
is what I'm pointing out. This false dichotomy. You said on our model, these meridian lines of longitude, they get further apart. Yes, that's because it's an AE azimuthal projection of a globe. It's a flattened out globe. With the pole in the middle, it's a polar projection, and Antarctica is all the way around the outside. Yes, but that's yours. It's not ours.
So I don't have a different reality where if there's a central point, which we're going to call the geographic North Pole, and we all walk away south from it, where we don't actually, we're getting farther apart from each other, that's a completely unique reality that I constructed, that I impose on you.
Geographic North Pole is on a map.
That's literally 5th grade geometry, how it works.
5th grade geometry, like angle measurements and stuff, yeah?
Yeah, that's okay. That's how it works.
No,
Yeah,
that's how it works conceptually. Okay.
No, literally.
No, okay. Show us some data. Show us some measurements. Show us anything.
Take a circle and draw lines from the center to the edges.
No, I said real world. I can't draw circles on the Earth.
You can draw a circle on a piece of paper. That's part of the real world.
Yeah,
he's talking about the real world.
Real
Peterson.
world.
Okay, go to
You're
Australia
saying,
and go south, and notice that you get closer together.
Okay.
Your model has failed. Utterly failed.
Wait.
Apologies to interrupt. Apologies to interrupt.
No one's interrupting. No one's interrupting. And hold on, Elpa. You can go out. This could take 1 second. Okay. So you have a model. You're claiming it works. How is that validated? In reality, physical reality, with people and instruments and shit like that.
What would you accept? Because I could tell you, you could.
Who cares what I accept? What's there?
Because I'll tell you something, and then you'll just say, well, you don't. What you're begging the question. You're
Just shut up
using
and give us the information, Planet.
Go on Google. You could go on Google Maps and do it, or talk to somebody that lives in Australia. Here's another thing. You can actually do this without any formulas. You could do this without any formulas.
Or back into the abstractions. Is science empirical?
Back into the abstractions. Going to Australia is an abstraction. Using Google Maps is an abstraction.
Yes, because it uses a coordinate
I'm
system.
sorry.
Yes,
You're
it's
too
an abstraction
to talk to.